you will learn about the different properties of a parallelogram. We know that the opposite sides of a parallelogram are parallel. Now, we will discuss some more properties of a parallelogram. First, let's name the parallelogram PQRS. The four sides make four angles. Sides PQ, RS, and PS, RQ form pairs of opposite sides. The sides which have a common vertex are called adjacent sides. Angles having one arm in common are called adjacent angles. Here, for example, angles P and Q are adjacent angles since they have a common arm PQ. Other adjacent angles in the parallelogram are angle Q and angle R, angle R and angle S, and angle S and angle P. Angles at the opposite vertices are called opposite angles. In the parallelogram PQRS, angles P and R are opposite angles. Similarly, angles Q and S are opposite angles. Now, we will learn about the property of angles in a parallelogram. The property states that the opposite angles of a parallelogram are of equal measure. How can we prove that the opposite angles are equal? Let's draw the diagonal PR. This diagonal will make angle 1 and angle 2 with sides PQ and RS, and similarly angles 3 and 4 with the sides PS and QR respectively. Here, angle 1 is equal to angle 2. The angles 3 and 4 are also equal by similar reason. Also, side PR is common to both the triangles. Thus, the triangles RSP and PQR are congruent by ASA property. This implies angle S is equal to angle Q. Also, angle P is the sum of angles 1 and 3, which are equal to angles 2 and 4, which in turn is equal to angle R. Look at this parallelogram. Let's join the vertices PR and QS. These lines are joining the opposite vertices of the parallelogram. So these are called diagonals. The diagonals of a parallelogram are not equal. One property of parallelograms is that its opposite sides are of equal length. To prove this, we will draw a diagonal connecting vertices P and R. The diagonal PR makes angles 1 and 2 with sides PQ and SR respectively. Similarly, PR will make angles 3 and 4 with sides SP and QR respectively. Now the angles 1 and 2 are equal in measure. Also, you can observe that the diagonal PR divides the parallelogram PQRS into two triangles, PQR and RSP. Similarly, angle 4 of the triangle PQR is equal to angle 3 of the triangle RSP. Also, the diagonal PR is shared by both the triangles. Therefore, both the triangles are congruent by the ASA property. Hence, side PQ of the triangle PQR is equal to side SR of triangle RSP by CPCT. Therefore, the opposite sides PQ and SR of the parallelogram are equal in length. Similarly, the sides PS and RQ are equal to each other. Finally, let's study a property about the diagonals of a parallelogram. The property is that the diagonals of a parallelogram bisect each other. Let's go through the proof. In the parallelogram PQRS, PR and QS are two diagonals. We will name the angles as 1, 2, 3 and 4 as shown in the figure. Here, angle 1 is equal to angle 2 since they form a pair of alternate interior angles for parallel lines PQ and RS intersected by the transversal SQ. Likewise, angles 3 and 4 are equal because PR is the transversal to the parallel lines PQ and SR. Also observe that PQ is equal to SR. Now the triangles POQ and SOR are congruent. This implies SO is equal to OQ and PO is equal to OR by CPCT. This implies diagonals bisect each other.